Welcome back to Steel Sea Giants, where we explore the most powerful naval technologies and the evolving future of modern maritime warfare. Today, the world's oceans are witnessing a massive revolution in combat tactics, driven entirely by small, cheap, and highly lethal unmanned systems. From the volatile waters of the Red Sea to the vast Pacific, modern navies face an unprecedented and highly complex asymmetric threat. We are seeing insurgent groups like the Houthis deploying low-cost explosive drones to harass and attack multi-billion-dollar warships without hesitation. Meanwhile, superpowers like China are rapidly developing massive drone swarms designed to overwhelm traditional air defense systems through sheer numerical superiority. This brings us to a critical concept in modern military strategy, known as the cost curve, which heavily favors the attackers today. Imagine a scenario where a state-of-the-art destroyer detects an incoming hostile drone flying just above the waves toward its exact position. The ship's commander must make an immediate decision to protect the crew, often relying on the primary air defense weapons available on board. Currently, that means launching an Advanced Standard Missile 2, or SM-2, to intercept and destroy the relatively slow and cheap flying target. Here is the paradox. The Navy fires a $2 million missile to shoot down a drone worth only $50,000. This extreme financial imbalance creates a horrifying waste of the military budget and rapidly depletes the ship's limited and precious missile magazines. If an enemy launches a swarm of 100 cheap drones, the defending warship will quickly run completely out of expensive interceptors. Once the magazines are empty, the multi-billion-dollar vessel becomes completely vulnerable to subsequent attacks, forcing it to retreat and rearm immediately. This strategic vulnerability is exactly what adversaries want to exploit, bleeding the world's most powerful navies dry through cheap and relentless attrition. To survive this new era of naval warfare, defense contractors are desperately racing to develop innovative, cost-effective solutions to hunt these drones. The primary goal is to completely invert the cost curve, making defense cheaper and far more sustainable than the enemy's offensive capabilities. Enter the new generation of dedicated drone hunters, designed specifically to neutralize low-tier threats without wasting our most advanced and expensive munitions. One of the most promising early solutions is the Coyote Block II, a small, highly agile, and relatively inexpensive interceptor missile system. Priced at roughly $100,000 per unit, the Coyote offers a much more reasonable financial equation for taking down drones. Instead of relying on a direct kinetic impact, the Coyote uses a specialized fragmentation warhead to shred the incoming drone into pieces. When the Coyote gets close to the target, it detonates, creating a deadly cloud of shrapnel that easily destroys fragile, unmanned aircraft. This system has already proven highly effective in combat environments, successfully defending military outposts and naval assets from coordinated aerial drone attacks. However, while the Coyote is significantly cheaper than an SM-2, firing a $100,000 weapon is still a major financial commitment. Engineers knew they needed something even more revolutionary to truly solve the economic nightmare of defending against massive, relentless, robotic swarm attacks. This urgent requirement led to the creation of the Roadrunner M, an entirely new class of reusable vertical takeoff and landing interceptor drones. Powered by twin miniature turbojet engines, the Roadrunner can launch rapidly from a compact storage box to intercept high-speed aerial threats instantly. What makes the Roadrunner truly special is its ability to loiter in the air, searching for targets before committing to a strike. If the threat is neutralized by another system, or if it was a false alarm, the Roadrunner simply flies back to base. It lands vertically, gets refueled, and is ready to launch again, drastically reducing the overall cost per interception to an absolute minimum.
This reusability completely changes the economic math of air defense, allowing commanders to launch interceptors proactively without worrying about wasting expensive ammunition.
The Roadrunner acts like a loyal robotic falcon, hunting enemy drones with extreme prejudice and returning home safely when the mission concludes. But having cheap interceptors is only half the battle. You also need a way to detect and track hundreds of targets simultaneously. Human operators, no matter how highly trained, simply cannot process the overwhelming amount of radar data generated by a massive drone swarm. When dozens of bogies appear on the radar screen simultaneously, the cognitive load causes human decision-making to slow down to a crawl. In modern naval combat, a delay of just a few seconds can mean the difference between a successful defense and total destruction. This is where artificial intelligence steps in, serving as the ultimate digital brain to manage the absolute chaos of modern anti-air warfare. Advanced AI systems can analyze thousands of sensor data points simultaneously, operating at what the military refers to as blinding machine speed. The artificial intelligence instantly filters out radar clutter, identifying true threats and classifying them based on their speed, altitude, and flight trajectory. It then automatically assigns the most appropriate and cost-effective weapon to each specific target, optimizing the ship's entire defensive grid in milliseconds. By removing the human bottleneck from the targeting process, AI ensures that the warship can effectively engage and destroy massive, coordinated swarms. The human commander still retains ultimate veto power, but the AI handles the exhausting, high-speed mathematical calculations required for multiple, simultaneous interceptions. With AI directing the battle, the warship transforms into a hyper-efficient killing machine, easily swatting down incoming drones with terrifying, calculated precision. Yet, even with reusable interceptors and brilliant AI, physical ammunition still takes up valuable space inside the limited hull of a warship. To achieve true invulnerability, the Navy needs a weapon with an infinite magazine, one that never runs out of bullets during combat. This long-sought dream is finally becoming a reality with the deployment of advanced directed energy weapons, more commonly known as combat lasers. Lasers offer the ultimate solution to the cost curve, providing near-instantaneous target destruction at the literal speed of light without any recoil. The United States Navy has already successfully tested and deployed the Helios system, a 60-kilowatt laser weapon mounted on active destroyers. Helios easily burns through the thin composite skin of a commercial drone in seconds, causing its internal batteries or fuel to detonate. The most astonishing advantage of the Helios system is its operational cost. Firing a lethal laser beam costs less than $1. As long as the ship's massive gas turbine engines are generating electrical power, the laser weapon can keep firing indefinitely without stopping. This nullifies the enemy swarm strategy, as the warship can cheaply and effortlessly melt hundreds of drones straight out of the sky. A 60-kilowatt laser takes a few seconds to destroy a target, which might be too slow for massive, hypersonic aerial threats. That is why the military is aggressively developing the Songbo project, a terrifyingly powerful 400-kilowatt laser system for future warships. A 400-kilowatt beam instantly vaporizes small drones and can even burn through the reinforced nose cones of incoming cruise missiles. The development of these high-energy lasers marks a fundamental shift in naval architecture, requiring future ships to generate massive amounts of electricity. While lasers physically destroy the target, there is another completely invisible method of defeating drone swarms that is proving incredibly effective today. Advanced electronic warfare is the dark art of manipulating the electromagnetic spectrum to blind, confuse, and disable enemy communication and navigation systems. Almost all modern military and commercial drones
rely heavily on GPS signals to navigate accurately toward their designated targets over long distances. Warships equipped with advanced electronic warfare suites broadcast powerful jamming signals that completely drown out the faint signals from orbiting GPS satellites. Without GPS guidance, the incoming drones instantly lose their sense of direction, drifting aimlessly off course and crashing harmlessly into the ocean. EW operators can actively target the specific radio frequencies used by the enemy to remotely control their unmanned aerial vehicles in combat.
By severing this critical command link, the drone is rendered completely useless, effectively turning it into a blind and dumb flying brick. Advanced electronic warfare systems can even hack into the drone's flight computer, forcing it to land or return to its original sender. The beauty of electronic warfare is that it costs almost nothing to operate and neutralizes entire swarms without firing a single bullet. It creates an invisible, impenetrable shield of electromagnetic energy around the fleet, offering a highly effective first defense layer against aerial threats. When we combine all these revolutionary technologies together, we get a truly comprehensive, multi-layered defensive network designed for the modern naval battlefield. The outermost layer uses powerful electronic warfare systems, attempting to quietly disable the drones before they even get close to the fleet. If jamming fails and the drones continue their approach, the warship launches a squadron of reusable Roadrunner interceptors to hunt them down. For targets that slip past the Roadrunners, the AI targeting system instantly unleashes a barrage of cheap, deadly Coyote Block II missiles. Finally, any surviving drones that manage to penetrate the inner defensive perimeter are swiftly incinerated by the ship's high-powered directed energy lasers. This layered approach ensures that the extremely expensive SM-2 missiles are strictly reserved for defending against high-end threats like hypersonic anti-ship missiles. Implementing these brilliant solutions allows the Navy to reverse the cost curve, making it impossible for adversaries to win through cheap attrition. The strategic implications of this technological shift are absolutely massive, especially when considering the rising geopolitical tensions in the vital Indo-Pacific region. China invests in swarm technology, aiming to use thousands of cheap drones to overwhelm American carrier strike groups during a major war. With lasers, AI, and reusable interceptors, the United States Navy can confidently sail into contested waters without fearing massive robotic swarm attacks. The ongoing skirmishes in the Red Sea against Houthi rebels serve as a vital testing ground for these emerging defensive combat technologies. Every intercepted drone provides valuable data, allowing engineers to continuously refine their AI algorithms and improve the effectiveness of their laser systems. We stand at the dawn of a new era in naval warfare, where software and energy replace traditional gunpowder and heavy explosives. The ships of tomorrow will look vastly different, bristling with glowing optical lenses and sleek drone launchers instead of massive gun turrets. These marvels ensure that oceans remain free and open, protecting global trade routes from the disruptive chaos of asymmetric aerial drone attacks. Let us dive deeper into the mechanics of the Roadrunner system and how it fundamentally changes the psychology of modern naval defense. Traditionally, firing a missile means that money is gone forever, creating strong hesitation for commanders facing ambiguous or unconfirmed radar threat contacts. Because the Roadrunner can return to base, commanders can launch it at the very first sign of trouble without any financial guilt. This proactive approach means the interceptor is already airborne and waiting near the threat sector before the enemy drone crosses the perimeter. The Roadrunner carries advanced modular payloads, meaning its explosive warhead can be easily swapped out for electronic jamming equipment or advanced cameras. This incredible versatility transforms a simple interceptor into a multi-role asset, capable of adapting to rapidly changing battlefield conditions in real time.
Consider the incredible complexity of artificial intelligence algorithms required to manage these diverse weapons systems during a massive, chaotic naval combat scenario. The AI must calculate the speed, altitude, and trajectory of 50 incoming drones, while simultaneously monitoring the ship's available power and ammunition. It uses advanced machine learning models trained on millions of hours of simulated combat data to predict enemy swarm tactics and formations. If the swarm attempts a synchronized diving attack, the AI instantly recognizes the pattern and adjusts the defensive laser firing sequence accordingly. This superhuman coordination is absolutely necessary because modern drones are no longer mindless, remote-controlled airplanes flying in a simple, predictable straight line.
Enemy swarms now possess their own artificial intelligence, allowing them to communicate with each other and perform evasive maneuvers to avoid interceptors. We are witnessing the terrifying dawn of algorithmic warfare, where our defensive AI directly battles the enemy offensive AI in the skies. In this high-stakes digital duel, the side with the faster processing power and smarter algorithms will ultimately dominate the future naval battlefield. Moving back to directed energy, the physics behind destroying a target with a laser beam are both incredibly beautiful and highly destructive. When the Helios system fires, it does not shoot a visible laser beam, but rather an invisible beam of intense infrared energy. This concentrated light energy hits the target and rapidly heats the surface material, causing it to melt, weaken, and ultimately fail completely. Aerodynamic forces then tear the weakened drone apart mid-flight, sending flaming wreckage tumbling out of the sky and safely into the ocean. Lasers are highly sensitive to weather. Heavy rain, fog, or dense smoke scatter the beam and significantly reduce its overall destructive power. This is exactly why the Navy cannot rely on lasers alone and must maintain layered defenses combining missiles, drones, and electronic warfare. The upcoming Songbo project aims to overcome these weather limitations by brute force, pumping 400 kilowatts of raw, concentrated optical energy. With that much energy, the laser can burn through fog and rain much more effectively, maintaining its lethal edge in adverse weather. Let us pivot back to the invisible battlefield of electronic warfare, the most cost-effective and stealthy method to defeat massive drone swarms. Modern warships are equipped with sophisticated antenna arrays that constantly scan the electromagnetic spectrum for suspicious radio signals or incoming radar waves. When a threat is detected, the EW system fires a highly directional beam of radio frequency energy to jam the enemy electronics. This targeted jamming is much smarter than blasting static noise in all directions, which could accidentally interfere with the ship's own communication. Instead, the system surgically strikes the specific frequency band used by the incoming drone, leaving friendly radio channels completely clear and operational. In some scenarios, EW can even spoof the GPS signal, feeding the drone false location data and tricking it into flying away. The capability to silently hijack and misdirect enemy weapons without firing a shot is the ultimate expression of modern naval tactical dominance. These incredible technologies, from the Roadrunner to AI and lasers, represent a massive industrial and financial pivot for the global defense sector. For decades, the focus was entirely on building bigger, faster, and more expensive missiles to counter major superpowers in conventional symmetrical warfare. The sudden proliferation of cheap, weaponized commercial drones completely shattered that paradigm, forcing a rapid and unprecedented evolution in modern military research. The defense industry realized that winning the future war is not about having the biggest explosions, but about having the smartest economics.
If you shoot down a $50,000 drone for $1 using a laser, you have definitively won the economic war. This economic victory is crucial because it demoralizes the enemy, proving their cheap swarm tactics are ultimately futile against superior defensive technology. Looking ahead, we can expect to see even more radical innovations, like underwater interceptor drones designed to protect against uncrewed submarine threats. The principles of the cost curve apply equally beneath the waves, where cheap explosive drone boats have already caused significant damage globally. To counter this, navies develop autonomous patrol vessels equipped with AI and small automated cannons to intercept surface threats at low costs. The ultimate vision is a fully integrated, multi-domain defensive network where satellites, ships, aircraft, and submarines share targeting data instantly and seamlessly. In this interconnected web, an incoming drone swarm is detected by a satellite, tracked by an aircraft, and destroyed by a ship. This distributed lethality ensures that no single point of failure can compromise the safety of the fleet or the sailors serving aboard. As we observe intense naval operations in the Red Sea today, we are watching the birth of modern warfare in real time. The brave sailors manning the radar consoles and weapons stations are writing the new tactical manuals that will define maritime combat forever. They are proving that while the threat of cheap drones is terrifying, human ingenuity and technological innovation can always find a solution. The era of the untouchable drone swarm is rapidly coming to an end, countered by the brilliant application of lasers and AI. The world's navies are adapting, evolving, and overcoming the asymmetric challenges posed by non-state actors and rival superpowers in contested global waters. By mastering the cost curve, the fleet ensures its long-term survival and maintains its ability to project power anywhere across the world. This is the true power of technological dominance, turning a seemingly insurmountable economic disadvantage into a crushing, overwhelming, and absolute tactical victory. From the blazing heat of the Helios laser to the silent disruption of electronic warfare, the future of naval defense is bright. We will continue to monitor these fascinating developments as defense contractors push the absolute limits of physics, computing, and advanced aerospace engineering. The race between offensive drone swarms and advanced defensive technologies will undoubtedly define the geopolitical balance of power for the next decades. Every new missile, every upgraded laser, and every smarter AI algorithm brings us one step closer to absolute supremacy on the oceans. The giant steel warships of today are transforming into highly intelligent, heavily shielded fortresses capable of repelling any attack from the skies. They stand as a testament to engineering brilliance, protecting freedom of navigation and maintaining order in an increasingly chaotic and dangerous world. As the sun sets on the age of traditional naval artillery, a new dawn of directed energy and artificial intelligence rises triumphantly. The future belongs to those who process information faster, strike cheaper, and adapt instantly to the changing realities of the combat zone. We have witnessed the death of the old cost curve and the birth of a revolutionary new paradigm in maritime defense strategy. The drone hunters have arrived, and they are ready to reclaim the skies, ensuring that the oceans remain safe, secure, and free. Thank you for joining us on this incredible deep dive into the fascinating world of naval defense technology, lasers, and artificial intelligence. If you found this exploration of modern warfare insightful, make sure to like the video and subscribe for more cutting-edge military analysis.
We will be back soon with more incredible stories about the massive machines and brilliant minds shaping the future of global security. Until next time, stay safe, keep looking to the horizon, and thank you for watching another exciting episode of Steel Sea Giants.